For people in Zoom, can you hear me? Hi. Let me have the Zoom on. So I guess I can do this. Let's see. So today's class is section E for 2011 DSME statistic decision. So I'm the instructor. The TA is not around. Already confirmed already. So we have Austin as a TA. So both of us will be can be office hour, can be made by appointment. So probably you want to know something about me because probably you want to decide whether to drop this class and choose other one, as although you can't really skip because this is a required class. So some background about me. So I have taught this class. This is the third time I'm teaching. So this is also the third year I'm in CHK. I was undergraduate here and got a master's degree here. I was when I was undergrad, I was doing in the B school, and then in the master, I do in the econ department in this building. So my research and the major when I was undergrad, I was actuarial science, and then I changed to econ, and so that's why I think I'm able to cover this class without any issue. Because this is a basic statistics anyway. So and I think TA Austin has been TAing for around 4 to 5 years. So I think he's also very experienced. And this course description, as this is a required course, and also basic course is same for every sections. Of course, different instructor may have different emphasis. But the main idea is already there, but I will go over the details of the content. But basically, is this: you have descriptive statistics, you have some probability, inference, regression, ANOVA, and probably later I will tell you a little bit more about that. But this is the same for everyone, and that's why the course outcome would be same. Okay, so to some of you may have known something about my class from last year. So this year there's some slight changes compared to last year. Is later you will see as you receive an optional tutorial on Python R. So in last year I cover both Excel and R in the class with lab section, and this year we don't. We still have lab section, but it's optional now. Okay. So Excel is still required as our syllabus, and Python R will be optional now. So if you want to join, you can join the optional tutorial on Friday. Otherwise, you don't need to bother. Okay. So and this also doing this way help us to save some time in the classroom and go over things more in more detail. But more or less the content is same. So there's looks like a lot of to cover, but later you will see at least half of them has been covered in your high school. So only half of them is not. So basically, if you study high school here in Hong Kong, and probably you will cover at least up to interval estimate. If you study M1 or up to M1. If you don't do M1, then probably at least cover the first 3 to 4 chapters. So, and for the last 3 things, the hypothesis testing, simple linear regression, and ANOVA will be very useful tools that you will use it for other classes. So you'll be expecting later you see a project that will be focusing on these 3 items. So basically, the course mainly want to teach you the last 3 items, the hypothesis testing, regression, and ANOVA, because the first few topics has been covered more or less, or at least it's not something complicated. Okay, we just give some mathematical foundation for those. Okay, and if you noticed, we will be the same as last year with tests, participation, homework, and projects. For tests, you will be at the end of semester, likely to be last Friday of the week 13th. Probably will be end of day, okay, at the night of the Friday night. So last year we have a 1.5 hour test, but I think this year we have make it shorter, 1 hour one, against open book. So you bring whatever you like to there. Of course, I will release more detail when everyone has decided to add or drop to decide final hour. But it will be the Friday of the last night. Sorry, the last semester, the end of the semester. So and participation will be 10%. Okay, so it's a very standard. And the homework will be the same. Okay, so we will be it will be again to just asking you some calculation, make sure that you know what to do. And the project will be the main thing that you learn from this class. Okay, although your assessment is based on tests, but the main learning opportunity will come from the project. Of course, you need the basic to know the test, but we are in B school, so application is more important. And the reason why the project is not worth a lot because there's a lot of subjective element around it. So I don't want to make it too high, but you should know that that is something you learn from this class is mainly the project. Although, I mean, the weight of assessment is a little bit different. Okay, but that's for the fairness reason, because sometimes when you do project, it's just like, I suddenly don't like it, or then I don't feel, I mean, it doesn't fit my taste, or it's too subjective. So I want to be more objective, to put it this way. But as and then description, I think is same for every class, so there's nothing new there. And the textbook, oh sorry, didn't bring it. This is same for every other classes. I think same for last year. Okay, so you may want to buy it or you may not. It's just up to you. I mean, because we don't assign any assignment from that book. So if you buy it, it's for your own reference. Okay, if you don't like it, you like it, doesn't really matter. And also there are some recommended texts. These 2 items are the same for every other sections. The only new thing I add is like here is something like if you want to know more, these are the books that you might want to read. But as far as we know, most of us are very busy. Okay, just save it for your reference in the future. You may need it. I don't think anyone would have read it anyway. So same evaluation and teaching feedback will be at the end of the term. So this is the course schedule for the 2 classes. Mainly same, but for our section, we will missing the Chongyan Festival, but it shouldn't affect anything because we have a Friday of the last week will be the exam, so we don't need to make up for that. Okay, so that should not be an issue here and there. And as I said beginning, For software programming, although Excel is something not very sophisticated, but for business applications, still a lot of people use Excel. It will not be going away at least within 10 years. Although if you want to do data science, then you should expect you learn some R and Python. I mean, C or C++ or other software might be helpful, but it's usually overkill. So usually you have Python and R should be sufficient. And as you said, as I said, I mean, like last year or in the black box, we have DataCamp. So we're lucky to have support from DataCamp. So usually it would cost several hundred US dollars to get a membership, but we get sponsored from them. So we can just go there and do the self-learning quiz there. There was learning, there was some, I think it's very useful if you want to try to learn it, the programming by yourself, if you start from the beginning. Although a little bit slow, but you always learn how to do things. So I recommend if you have time, you can go there and register yourself using the CUHK ID. Your email address should be able for you to register. And remember, because this is only for our class, so don't dispute outside our sections, okay? And honesty thing, because for the math class, I expect you do your homework or project, you're not copying from others. I mean, it's all for your own learning. The only thing you need to do this is for your project. You want to check whether you're not plagiarizing. But as you will see, there's not a lot of writing because later you go over the project, you only limit to 2 pages. So I don't think you need to copy anything. So I don't think it applies, but just put it there in case everyone have to do it. So it's a standard stuff. I'll go over more detail about our course material, topic cover, and also the homework, and also the test and other project later. But at this moment, is there any question before I proceed? So this is more or less about me, about the course, and of course, you care about the assessment. But I think I have history of how I give grades, so I mean, it's not something unknown. Any question? Those in the Zoom, is there any question? If no, then we go to talk about next thing. No? Zoom can hear me or not? Because I can't see anything, but okay. I mean, since Zoom people is not talking, but I mean, maybe they just go somewhere. Oh, okay, still here. Good. So the next thing I want to go over is go to a black box and go to every single element there. So go to the black box. So the black box here I just cover is the course outline, okay? And the tutorial syllabus, I just very briefly go to that. I mean, so your tutorial for the computer programming will be Xu Liu. She is a PhD student, second year, yeah. So she's doing applied econometrics, so statistics is not an issue for her. So you can go over in the detail because it's optional, but you will see is the tutorial start from next week. Will be on Friday. It's optional, it's computer lab. So it will be combining section C and section E. So you can go, or you may ask your friend to go, or you may ask her if you see the slides or whatever if you are busy. So you'll be covering R and Python. It's totally optional. So if you like to go, you want to go, or you don't like, just go to DataCamp, or you don't have to do R and Python in your class. Okay. But of course, I would say if you have some little minimum knowledge of R, will help you a lot in your future. I mean, of course, for those you already know some programming, I mean, still worth to go. But so this is the item number 2. Item number 3 is overview of the topic. So this overview, as you will see, this try to break down what we learn. Basically, it's 8 topics, okay? And as you will see in this file, I have talked about each topic, and probably each topic will last for 1 or 2 weeks, okay? For shorter one will be 1 week, and then you add up to 16 weeks, so 13 weeks. And as you can see, just want to highlight is when I have a superscript JS means you learn it in junior school, and with your SS you learn in senior school. The one junior school and senior school refer to Hong Kong math high school syllabus, school syllabus. So you have come from Hong Kong, and most of you do that we will learn already this kind of thing. And I also write was M1, which is covered in M1 syllabus. So you will see most of them is covered already. There's something new, shapes and correlation coefficient, and a probability. You learn most of them. If you don't from M1, you don't learn base rule, but most of them are covered in the senior school. And for topic 3 random variable, you learn most. If you learn M1, you learn most of them. If you don't learn M1, if you have a senior school here, you learn normal distribution, and that is something what we need the most. And topic 4, they cover M1 as well. And topic 5 also M1 as well. And 6 and 7 and 8 is not covered. Okay. And then as I said, at least half of, if you do M1, you will see at least half of them. And if you do high school in Hong Kong, which I expect, if you from other place in the world, then you'll be similar. So at least 1/3 of them is covered. Okay. So but of course I assume we don't have any knowledge from now on, and I try to go slow. But if you think I'm too slow, just say okay, I'm too slow and to go faster. So that's not a problem. Just very briefly to go about what we are covering in this whole course, hopefully in 5 to 10 minutes. So basically, topic 1 is descriptive statistics. Basically, it's something very simple. We have some data. We want to tell what's going on there, okay? Because data is usually a lot. And now with big data, you have billions of observation. And how to come up with some number that represent data is our topic 1. Okay, maybe some graphic, maybe some number, maybe some trend. And that is something we do the first chapter, okay? And for the chapter 2, we will talk some math, okay? Because we will need to learn some probability, and then you may ask why probability, okay? The reason mainly because we are never able to collect every single information that we need to do analysis, okay? Suppose I want to know what is the effect, okay? Or what is the impact of, say, eating certain kind of fruit or certain kind of food supplement, right? And to say, then you have to ask everyone in the world to do it and then see the result, right? But the thing is, we can never be able to ask everyone, right? Just like you have a medicine for the COVID, right? Then you cannot ask to put it to every single person before you have the result, right? Otherwise, it's too expensive. So it requires us to do some selection or called sampling. We're going to not observe everything we want to do. We will only observe subset of it, a small subset of it, a small part of it, and try to use the information from a small part to put in the big picture. Okay, so it requires, because picking something, then we're not doing the whole picture. We're doing part of it that requires to use probability theory. Okay, that's the reason why I focus on that on the topic 2. Is a classical way to do it. Of course, every one of us will have some idea of probability. Okay, we know what probability, right? The toasted corn, the fair corn is 1/2 is head, 1/2 is tail, right? So we know some idea of that, right? So it's not a big deal, but we just need to learn some more tricks in the way to give the foundation what we're going to do. Okay, of course, this is something we will remember some rule there. Okay, and then chapter 3 will be something related to chapter 2. Okay. The idea is that chapter 2 is talk about probability in general, and usually it's very complicated, okay? And because like I took a coin, okay, and once, it's just only head or tail, right? If I post twice, I can have 4 different outcomes, right? Give me first a head, second is head and then tail and then head and then tail, right? If 2 times, it's already 4, right? You can imagine 10 times. How many outcomes we have is around 1,000, okay? That means that if you have many toes, even just very simple outcome, head or tail can be very complicated, okay? So usually we are not interested in the details of outcome. We try to simplify it. The simplification process is called random variable. Just put it in a simple word is we just record the outcome in terms of number 1, 2, 3, 4, 5, right? Or actually something we observe in the real world is always a number, right? Look at the Hong Kong is financial market, right? The financial market is some stock goes up, some stock go down, right? And then what we usually learn how well the stock market is doing is Hang Seng Index or other index you may want, right? And Hang Seng Index is a summary of what happened in the stock market, right? So we just basically what we call random variable, okay? And once you have 2 and 3, basically is the background or the math required to do the rest of the course, okay? And we have sampling distribution, okay? As I said in the beginning, we want to use data to infer what's going on, what we want to study, right? And sampling is you try to pick up something there, right? You need to learn how it looks like, what's property. That is why we learn sampling distribution, okay? We learn when we try to draw some sample, we have to try to study a subset of it, okay? We want to do some study, some experiment, right? What's going on, okay? Because of this sampling distribution, we can do the rest of the 4th chapter, which is the main thing, right? First is we want to do estimation, right? That's something we want to do, right? We want to know how useful are things, right? Something we don't know, right? For example, we want to know how useful is the COVID medicine or the vaccine, right? We want to know, right? So what we do is do some estimation. How likely that after taking the vaccine is going to help you to prevent disease, or how likely doing a test so that guy have a COVID, right? I mean, you need to have a data, okay? And estimation is the way we study part of what we want to study, try to infer what's going on in the big picture, okay? So that's estimation. And hypothesis testing is something very often we use in experiment, or we want to prove something is useful, okay? And or in terms of accounting, it's audit, right? It's going to see whether something you're going to, if you're accountant, your auditor, you go to a company and check their financial statement or income statement, or whether the inventory check, right? You're not going to check every single item in the list, right? You randomly pick up a location and randomly pick up a warehouse and pick up a particular stock, right? Good, and to check, right? Whether they have that kind of inventory, right? And you want to try to check how many items I'm going to pick, right? And whether checking is going to consistent with the financial statement, okay? And those are things that require hypothesis testing, right? You want to check whether a certain claim is true or not, okay? Or you are quality controller, right? And your research department said, okay, this new way of production can extend the shelf life of the product for 10 days or 1 year, okay? It's more expensive or whatever, okay? So before you really implement this new production technique, you want to check whether what he claim is right? Then that's hypothesis testing. You want to see a claim, which hypothesis is supported by the data or validated by data, okay? This is often used in the courtroom, right? And you in the classical British system, judicial system, is assume the defendant is not guilty until proven otherwise, right? In some other place in the world, you other way around, you assume that guy's guilty until you prove you're innocent, right? But there's another story there. But that is the hypothesis testing. And the last one is a very useful technique. And hypothesis testing, usually you want to so whether something is useful or not, right? Whether you take the medicine is going to help or not, whether the new process is going to save money or not, right? Usually yes, no question, okay? And ANOVA is, you can imagine, it's a more generalized hyper-testing, okay? Say if you want to see, say you have suppose a manager, okay, of a hotel chain, okay? You have 3 hotels, say Hong Kong, Kowloon, and New Territory, okay? And then you want to see, okay, is this 3 hotel having the same occupancy rate or making the same profit or so on and so forth, right? You want to see whether they're different, okay? Then in that case, it's ANOVA. Or you want to compare 3 different kinds of treatment and whether they're good or not, okay? You want to say some things like, okay, so as a manager, I want to decide whether he is going to be eligible for promotion, okay? And somehow when he's working, say, again, the hotel story, he was in New Territory, okay? And New Territory may be bad, business is not so good, right? He doesn't do so well in New Territory. Is he do particularly bad, okay? So that will be using ANOVA to see whether him in the New Territory particular location is bad or not, okay? So it's like the multi-factor analysis, okay? So they're basically just like we have several treatment and we see whether treatment are the same or not, okay? It's very useful in medical tests, right? You have, say, you have treatment A for this group patient, treatment B will be the 2 group, and treatment A and B and the other group, and A, B, C, D, E, F, G, and then you try to see this is a more like generalized hyper-testing, okay? The last one, the regression, is a even more general than ANOVA, okay? Basically, in the math sense, right? You are talking about the relationship between a discrete A and B and C, how the outcome, okay? And regression is not about A and B and C, it's not continuous. So suppose I want to see, probably you care, is in economics, the often study say number of years of schooling impact on the income, okay? I spend more time in school, is it going to help my earning, right? Or is my GPA go up by 0.1, okay? Is it going to make me richer in the future, okay? Whether I need to study in the library for this class, okay, to get an A rather A minus, okay? Or I just stay at home watching YouTube or Instagram or TikTok, or just sleep, okay? So it will be, regression will be the most often used tools in economics that are basically trying to discover causal relationship, okay? Try to see if something has some impact, okay? Of course, we are not going to that detail, but this is, if you study econometrics, that basically the whole course will focus on this one. So, so that will be the thing, and then someone of you may know some of the machine learning method is basically or artificial intelligence. It's basically regression. Just keep running regression, try to predict, right? Because you're trying to say the machine learning, right? Just like the auto self-driving thing, right? It's just like you observe a picture and try to detect whether there's a guy, there's a dog, there's a road go on, right? How do they learn? It's just like you have a lot of input and come out output, right? And then how do you best fit that? The regression idea, okay? How to best describe the variable, this relationship is what we call regression, okay? So I guess more or less I want to say about this, but of course, probably you may not understand most of the thing, but I just give you the idea what's going on there. And if you want to know already, the slides for the whole semester already there, okay? Unless there's a material mistake, I will not correct it. So you can just, if you want, you can download or not. I'm not changing, unless there's some issue there. But otherwise, shouldn't be big issue. Maybe there's some 1 or 2 typo. But I hope after 2 years, the typo should be gone. But I guess if you find out typo, then let me know. But otherwise, I think that will be fine. Any question about the topic we're covering? If no, just let you know, this is the time. I mean, this is the today. I don't think you will forget, but first day we have 4:30 to 6:30. And as I said, the slides already there, so we can see it. The main difference between this year and the last year is just I take away the R. Okay, and the R, and I add some new graphic here, but basically the same thing. Okay, in case you're using your slide from the senior guide, it should be fine. Okay, doesn't really change that much. I add some pictures and add 1 or 2 examples there, but most of them basically the same thing, just no change in material. And for this class, I have create textbook here. So basically, just it contains everything I want to say, and you also some extended material there. And as a student, I don't want to buy books because it's heavy. And also in statistics, there are too many books in the library. So I try to get what I want to say in here. Of course, this one would contain more than I want to say. The most useful thing in this book, I would say, is exercise. So the book contains exercise with full solution. Let me see. So we have a multiple choice question with answers, and also long question with answers. Okay, so I would recommend, if you have time, you want to do it. If you don't have time, at least look at how I do it. Okay, so that would be most useful one. And of course, in the class, we can't cover every single thing. So in case you find something you want to know more, you can read the book. Of course, now with internet, easy. Okay, in my days, internet is not that convenient. Wikipedia is not there. So, but I'm assuming for you, it will be not difficult. If you find something is not in here, you want to know more, let me know. I try to see if I can help. But otherwise, this book will be contain everything I didn't explain in detail in this book. Okay. And the last thing I want to go about is the projects. Okay, which worth 20% of the grade. Okay. So as I said, that will be, I guess, will be the most useful thing in this class, because once you do it, you learn how to apply the technique there. Okay. And you can consider an open, although I call project, you can consider open-ended assignment. Okay. And the deadline will be the 4th of December. I think 4th of December is the Sunday. Okay, the last week. So student affect your exam. Okay. And exam will be on the 3rd. Okay. Oh, sorry, on the 2nd of December. After the course at job period, I will send out when the time, but likely will be at night, maybe 6 to 7 or 7 to 8 or 8 to 9. Yeah, depends on, or maybe 7:30 to 8:30. I mean, depends on, or maybe earlier, because we just only take an hour, so it wouldn't be an issue. So as same as last year, I want to allow feasibility of making a group. Okay, because of the COVID and other thing, you may want to do it by yourself. Okay, or you do are very a lone wolf, you want to do it by yourself, or you are very have a group spirit, you want to do it with your friends. It's also okay. Okay, but I have to, only restriction I have is I put a group size, maximum group size cannot be more than 6. Okay, the reason is everyone doing in a one group, then I cannot grade. So I have to have some maximum. Of course, if you want to go over 6, then let me know if I can see if you really worth more than 6. Okay, otherwise, I mean, I assume 6. So because of you can do it by yourself, I do not entertain any complaint about your group mates free writing. Okay, you don't need to tell me your group formation. You can break down, you can break anytime. Okay, I just need you to submit the final thing. Okay, so you don't need to tell me that guy is not doing the work. Okay, you can just submit your own. Okay, we are not going to handle, okay, this guy is doing the bad thing. I mean, I'm not going to hit it here and there. Okay, you can do, you solve it by yourself, or you can just if you do in group, I assume everyone contribute equally, unless every one of the group send me say, okay, I'm not doing the thing, I get little minor mark, okay? If I have that kind of letter, it's fine, but otherwise I will assume equally. And for the report, I'll go over example later, okay? But there's only important thing is page limit, okay? So if you are the only one in the group, you can only submit me this one page, like 2 pages, okay? Okay? And if you have 2 people, then you have 2 papers, okay? So no more than that, okay? Because you tend to write a lot. And in B school, who is going to read more than 1 page, right? I give 2 pages very generous already, okay? So no one's read more than that, okay? So show me what you want to show, okay? And as I said, you need to do the plagiarism, okay? Thing. And I mean, I go to the examples to make sure that you don't feel very anxious of what to do. Because when I was a student, whenever the class have a project, I will feel, okay, what's going on there? It's not going to clear what's going on, okay? So now I'm a teacher, so I want to say, okay, I'll show you example, what is already there already, but I just go over a little bit, and you will see what has been done, and it's not something difficult. So don't, your answers level can be dropped. So I put all these things here, just like I think it's interesting, okay? Or at least look good, okay? Above average, doesn't mean everyone got A here, okay? Some of them is good, some of them is bad. But some of them is average, not bad, but I mean, I exclude things below median, okay? But say suppose this one, trying to look at is in this, the intermediate player for tennis, they want to play tennis and try to see whether different type of courts could make a difference, okay? So they do some t-test and check whether this thing, okay? So they within the page limit, they have 4 page limit, but they use 3. So you can see you don't have go over that, but you can see they designed this very nicely, okay? It's not something very difficult, okay? So they conduct some data and do the thing, okay? Let me go to the other example. I just randomly pick up. So this group look at the graphics, okay? And try to see data from different gender, different region. And they will use regression, ANOVA, hypothesizing, and estimation. Basically use everything in our class. So basically what they do is a little bit interesting because they do some survey. I think they do the online, they don't do the library, but they collect people from different areas in the library or online. And then they ask the question like, okay, whether a man or woman would do Netflix differently. Okay, I don't know, what do you think? I mean, for example, I don't watch that much. My wife watched a lot, so not sure. But my son watched a lot, but my daughter didn't watch. So in my home, it's like, I don't know. I mean, there's no, it's not clear what's going on. But and they want to see whether the mean is the same or not, right? This is what the hypothesizing is doing. And then whether location has any influence, right? And location and gender are discrete things, just like ANOVA, standard thing. So want to see if each group is the same, right? Because you have 2 by 2, right? Sorry, more than 2, but Thailand, Hong Kong, and male and female, and this is what they do. And whether watching more Netflix make you happier, okay? That's what they do, right? Because you would expect, hopefully, watching more Netflix will be more happier, or other way around, you watch Netflix because you're not happy. But I mean, so what they found is negative. So maybe you are sad, you're blue, you watch Netflix. What they found, but so that is something like this. So you can do. There are a lot of things more, but I'm not going to go over it. You can check out every single project there is open there. So you can check out what kind of idea you can generate, and then you can go to work out. Okay, so you can do whatever you like, as long as you think it's relevant. Of course, hopefully the better with the business, right? Because that will be fit our theme. But if you really want to do, say, vaccine thing, right, COVID thing is, or tennis thing, you see, is also fine. Okay, If more or you fit something what you feel you like, you can do some survey of the thing you like. Okay, so as long as it's fun, interesting, you learn things, that's good, right? And is that a question? Any question? Let's see what we still have to do. So maybe I go over one more because I think we still have some time. Let you see a little bit more. So this one's also interesting. It's about personal finance. It's a look at your income and your expense, right? You can see income expense is you can use regression. Clearly, the last thing we do, right? Look at how the young adults money, how the income, are you earning more and spend more, okay, or not, right? Because someone's occupation is sons and daughter, which have no budget limit, right? So is it girls spend more than boys or not? Okay. So then what they're doing is very nice summary, because I would see this executive summary is very nice because when you read a report, you want to really know what's going on, what's the question, and what's that. I think this is a very nice one. And then they compare what they do. And indeed, I would recommend you for this particular report, I would expect you write the answer here as well. Okay, because I want to see what is your question. So what is the problem, right? Your motivation. The second paragraph is your question. And the third one would be give me the result quickly, 1 or 2 lines, right? You think yes, no, yes, no. I mean, that will be a nice one. Okay. So what they do is do online questionnaire, and I think it's CHK there. And they do a lot of things. And this is the details, right? And they do a lot of stuff. Okay. Whatever. Okay, lots of conclusion here. Okay. So what they first do is look at the mean. Maybe look at this one. They do estimation, but estimation is not particularly interesting, but just at least we say what's the monthly income. Okay. It's 3,000 to 4,000 something. I don't know whether it fit your intuition. And in general, expense is like 2,000 to 3,000. Oh, it's good. At least people don't spend more than what they earn in general. And they want to check whether male or female are the same or not. Okay, what is your guess before we go to the answer? Male, those who think male, raise up their hand. Those who think girl, raise up their hand. Okay, you think the same? Okay, that's good. So let's see what is the question here. Okay. Turn out to be, I think what they do is different. I think they have interestingly, I think in this model, they think men spend more money. Okay, which a little bit surprised me. Okay, I mean, I don't know. In this one, they look at that's the income. Okay, income male earn more. Maybe that's right. Okay, yeah, that is possible. In this one, is it men and women spend the same amount of money? Turn out that is same. Okay, so interesting, because look at the data they have is that the survey that men would be earning more money. Okay, and they spend the same. Okay, so men save more money. Okay, for some reason, maybe they need to pay for the bills for the girlfriends, right? Or save money for buy house for whatever reason. Okay, men keep more money. And is it going to be earn more, spend more? The answer is yes, the slope is positive. So I think X is the income and expense. This is called the scatter plot. We'll cover on the chapter 1 is like if higher this and higher that. So it's a linear line there. Regression is basically in this plot, you'll find best line. Okay. So basically, you can, from the project, you can see you almost learn every single important thing in this class. We just need to know how to operationalize those. Okay, basically you learn the very important thing in our class already. Okay, now it's 1:15. So I guess I should have a break of 15 minutes. We'll resume in 1:30. So in case you want to drop it, then just go. Okay, I will be disappearing for a while. So I will see you in 15 minutes later. In the meantime, yeah, if your question, just ask me. So for those in Zoom, we'll see you in 15 minutes. So we'll be talking about slide number topic 1 today. So walk around. In case you have a question, you can ask me. Maybe I switch off the mic first. Hi. Okay. So for those who want to leave, I hope they have left. So hopefully remain review that you taking the class. So today I'm going to cover some part of the descriptive statistics. Maybe you take 1 or 2 weeks to cover it. Just that you know, once we have finished a topic, then we'll give you the assignment. I think assignment maybe 1 week or 2 weeks, maybe 1 week or 2 weeks, allow you to do it. I think maybe 1 week, I guess. It's not something technically computation heavy. I mean, as you can see from the previous years, homework is not something too much calculation. It requires some time, but shouldn't be causing you too much time. I will see. We'll talk about assignment at the end once we finish this topics. So you see from this first slide has more than 100 pages. Don't worry. The main content is up until somewhere 30 pages, 40 pages. I think the main content is only up to halfway, and the other halfway is just for Excel. Okay, the Excel has many pages because I want to show every single step there. Otherwise, the main content is not, and a lot of graphic in this one. So this is a unusually long chapter, but nevertheless, I think it's one of the easiest thing because most of the concepts have been learned in high school. Okay, at junior high or senior high, but you will be something easy. Just a gentle reminder, my surname is K.O. So I don't know whether I should put surname first and surname last, but I underline it and capitalize it. Then you know when you try to email me, so you know what to write. Okay. Well, this confusion because in Hong Kong, CHRU Chiu is also a surname, so probably people confused. But I hope that is not. I'll make it clear now. So this is statistics, and statistics classically divided into two different categories. Usually, if you learn this from a stat department, they will divide into two courses. And indeed, when I was learning this 20 years ago, in here, they divide in two courses. Okay, the first course is descriptive statistics, and the second is inferential. And basically, in our class syllabus, is basically the first two topics is descriptive, and the remaining topics are inferential statistics. Okay, descriptive statistics is basically what you learn without learning about probability. Not probability there. Just simply your data. You try to clean up the data and make it clear to understand. Okay. And there are two, different ways to represent it. One is visual, one is numerical. Okay. And since almost everyone learned it from the junior school, right? The bar chart, all the thing. I'm not going to cover those pie chart, bar chart, pictogram, histogram. I assume you learn it. Okay. If not, go to YouTube and learn how to do it, or ask your cousin how to do it. Okay. I'm not going to have assignment, assign you how to draw a pictogram or those kind of things. Okay. For new diagram like box plot or scatter plot, I will talk about those. For those you should have learned, you will be able to learn it. Okay. I'm not going to repeat because otherwise it become a kindergarten school. Okay. Even my girl in kindergarten learned bar chart, pie chart. Okay. She is like 5 years old, so already learned it. So if you forget, ask your 5-year-old cousin. That means he or she can tell you the answer. Okay. And what we focus on is numerical representation. Okay. And then we'll cover mean, variance, all those kind of stuff. Okay. Although we focus on numerical, okay, and because we're B school, the visual part is very important. Although I don't talk about those, okay, it doesn't mean they're not important. And use it wisely. How to use table, how to use those diagrams is very important to convey your message. Okay, we're not covering it. It's not because it's not important. It's just like you have to know it and do it in your project. Okay, we're not saying it's not there. And the second was inference. Okay, and use data to do things. And as I told you, this class learned several things, right? Estimation, we learned hypertesting, ANOVA, and regression are the 4 things we learned from this class. And you can see a lot of things in economics or business world is a lot of things we estimate demand, elasticity, predict economic growth, what's the interest rate fluctuation. All those things are based on statistics, right? We'll have a model to predict what's going on in the future. Unemployment rate, with the interest rate in the next meeting is going to go up by 50 basis points or 75, or 1%, right? Or 100 basis points. So it's a model, okay? And basically based on data. Okay, so in this class we focus on the first one. Okay, and in between we have probability theory, right? So that is to jump from here to here, you need probability theory. So that's the topic 2 and topic 3. Okay, I hope it's already very clear. So just a kind of definition, and it will be important as well, is to distinguish our data. Okay, and I have to emphasize that you have to know this very well about your data, because some of the method doesn't apply for some data. Okay, and it will be more clear what do I mean by that. And so let me talk about this, and before I will talk about some caveat why we need to distinguish carefully. Okay, the first one is numerical data called gender. Someone's coming in. Okay, it's called gender and race. Okay, and these are data that that just male or female, right? Whether your race is whether you're Chinese or Japanese or Korean or what. And these, when we have data, maybe you put a number 1, 2, 3, 4, 5, but this number are meaningless. Okay, don't try to compute the average race, or average gender, or median gender. Those you cannot compute. Those are meaningless. And the second one is ordinal. Ordinal, that's like ranking, right? You say 1, 2, 3, 4, 5, right? Or you go to horse racing, the first horse, second horse, third horse. Or Miss Hong Kong, you have first, second, and third, right? And the number only means the higher the better, or smaller better, depends on what you're talking about. But the difference between number is meaningless. Okay, if you try to calculate later with an average or the mean or the median, usually it's not very meaningful. Okay, and because depending on how you put things, like the way often it's called Likert scale. Okay, and you say have strong, disagree, agree, agree. You see a lot of rating, and every time we oftentimes see the average of this score. Usually it's a lot of misleading, right? Because the best case is agree, you put 5, right? The strongly disagree is 1, say usually, right? And usually do the average is also misleading, because later you will see the misleading about average is it will be easily changed by the outliers. And most of people would get this, right? But 1 or 2 very low number will distort the mean. Okay. So that's why in this context, it's more meaningful to talk about mode or median, right? Because adding things doesn't really mean a lot, right? Because average, I assume you know, but we'll cover that later. It's adding numbers up and divided by how many of them, right? And adding this number, because number by itself is no meaning, right? Doing the average doesn't mean a lot. I mean, of course, a lot of cases you go to Amazon or go to all the e-commerce platform, they put all the rating average one, okay? But this is not really useful. But I mean, people still use it, but you know they sometimes mislead you. So I mean, yeah, but you just know what you should do. And for numerical data, you don't have problem, right? You have discrete data or your continuous data, right? Discrete data is count, right? 1, 2, 3, 4, 5, right? There's no intermediate. And continuous will be Hansen index, so on and so forth. Okay? So when you apply a technique to this 2 is not issue, right? When apply to the first 2, you will be some issue there. Okay? You can run regression among this, that's no problem, right? And when you do ANOVA, right? Comparing treatment, ANOVA, right? The type of treatment is nominal data, right? Whether treatment A or treatment B or treatment A and B, right? Those kind of thing, okay? And ANOVA, when you have, basically you have 1 variable for category, 1 variable for numerical. But I mean, of course, you will talk about more detail later, but you will see regression, we're using all data here. ANOVA is 1 from the categorical, 1 is discrete, right? So this is, sorry, 1 is numerical, 1 is categorical, so ANOVA. both of them are numerical or regression. So that's why you need two different type of style of tools. But anyway, I hope this is rather intuitive. And as I said, I expect you to learn this by yourself, or you have learned it. No, we'll cover it. It's basically, you can do pie chart or bar chart for discrete data. Continuous data, you go histogram or polygon. Scatter plot and the line chart. Scatter plot, we cover it. So I mean, I expect you the first four. I'm not going to cover it. Okay, the bar chart, histogram, you learn it by yourself. Of course, I will not explicitly ask you in exam how to plot a bar chart or pie chart, but you should know it. I mean, and then you should able to represent those data by in your mind by yourself or in your project. So that is something I want to say. I mean, I assume you know, but we're not going to test on something via assumption, but just so for this topic 1, we'll cover 3 different types of measure. For those who have learned math in the junior school in statistics before, you learn the first 2 objects. The last one is something you haven't learned, or you may have not learned, but you may be aware. But the last one will be the most complicated. Okay, and the first one is single tendency, and the famous is the idea is like if I allow to use single number to represent whole data, what kind of number I'll use? And there are 3 choices: mean, median, and mode. And you will notice, depend on what kind of data, should pick those, right? Say for nominal data or categorical data, then you know you should not choose median or mean, right? So choose mode, right? For you have some number there, then you call it mean and median. And these 2, mean and median, later you will see these 2 common modes measure. When to use what? Of course, you should use both if you can, but which one is more useful? Depend later you learn we call skewness. Okay, and if the data is skewed, then you should use median. Just like income, right? If I try to average I and the rich guy, Bill Gates or Elon Musk, add together, the average is very high, right? It's not meaningful. But with median will be more useful. But we'll talk about this in more detail. But I assume that actually you know it already, but just go to in the more technical sense. And the second one is called dispersion. And dispersion is how spread data is. Okay. And in some sense, it's talking about how good is our central tendency measure. Okay. If the 2 observations have the same mean, same median, same mode, okay, but one have higher dispersion than others, okay, more spread out than other, right? Then the less spread out one, okay, is better represented by the mean, median, mode, right? Because the data is all more around those central tendency, right? So there's better measurement. So it's the accuracy of that, okay? And you have a interquartile range, variance and deviation, okay? That's the main thing of those, okay, or range on those things. And lastly, we talk about the shapes. And shapes, we have skewness and kurtosis, okay? For skewness, I already mentioned, it's a data in the rough sense. Skewness is asking whether median is bigger than the mode or mode bigger than median, right? Or in more generic sense is whether there's a lot of data at the far end or the left or right, okay? Say the income, okay, most likely is skewed to the right because there are a lot of super rich people earning so much money, right? Calculate average in those cases mean a lot. You should use median, right? And skewness also sometimes skewed to the left hand side, skewed to the 0. Like what is the average number of people having disease, right? Most people don't have disease, right? Most of people are 0. So suppose you got a guy who got disease is 1, though this is 0, what's the average of this number? On average is very close to 0 because most of them are, I mean, every day only have 10,000 people got disease, right? And more than 5 million people have nothing, right? So we have a lot of zero and bunch of ones. So it's not very symmetric, right? So that is that would be skewness was going to do. And skewness means the mean is not very meaningful, okay? If the more skew you have, the median is more representative, okay? So that's why we look at the income, look at the median income, right? You not look at the average, not very useful, right? When we try to look at what is, say, you want to do, I don't know, medical school, or you want to do law school, spend more time than normal, right? Then you really want to look at not the average income generated from taking extra 1 or 2 years. You look at median, right? Because there's some guy making a lot of money that is possible, right? Maybe there's a very famous doctor, very famous lawyer that make huge a lot of money. But look at the median would be more useful, right? That was the thing. Now, last one is kurtosis, okay? This one a little bit more technical. Kurtosis is, you can imagine it's related to the dispersion idea, okay? It's more dispersed, you have larger kurtosis. But it's not talking about how the data spread compared to the central tendency. It's talking about how big are the tails, how big are the extreme values. If the extreme values are very extreme, okay, then kurtosis is very big, okay? And you may ask, what is the purpose of doing that? Because later, I mean, we will be using this is because in our course, probably you learn in high school too, is what we call the very famous one thing you learn in statistics. In this class is what we call central limit theorem. What is it is everything we want to do, want to make a bell shape. Okay, want a bell shape. And you want to see what the bell shape applies, is look at the kurtosis. If the kurtosis is too big, then using the bell shape idea doesn't really work that well because the two tails are really extreme, okay? And there is application in actuarial science or insurance or financial market is because of their extremely risk is called catastrophe risk, right? The earthquake, probably you know recently, last night I think in Sichuan, Chongqing, there's an earthquake there. So this thing can generate a lot of damage, right? And in this kind of thing, it's like unusual event, right? And cause huge damage, right? And this thing means those differences are called flat tail, okay? And or financial market also, there's a financial crisis, things goes on, right? And things become abnormal, right? Like what we are now here is COVID is an abnormal thing, right? But if you are financial market, you have to price those kind of in. If you don't, then you lose the game. Indeed, some research have shown in the 2008, the financial crisis is because of the failure to take into account kurtosis, because they don't take into account of extreme risk coming from the subprime mortgage, right? And also in the 1997, during the Asia financial crisis, one of the very famous fund called long-term capital management or other things or other fund go bankrupt or lost a lot because they failed to take into account of, say, the currency peg is destroyed in Indonesia, and also the Russia and Asia country, then go a lot of country go bankrupt. Not go bankrupt, but just default their debt, and then those company buying those bonds actually got nothing. Okay, so that is kurtosis is something very useful in business, but because extreme, you can imagine this is called extreme risk in your mind, extreme distribution. So that is the symmetry is extreme risk. Okay, these two are somewhat technical, but it's very useful. Okay, because if you know your data looks like this, then you should be more careful. The traditional tool you use have to be tailor-made for those. Well, of course, we don't learn this in our course because our course just focus on the main thing. But your data should show you whether what you're doing should be the right thing. Okay, for those from the medical school, right? Then you will notice these things are also important, but they are seldomly take into account in medical study because of the sample size of medical study is rather limited. But you can imagine these kind of things should be important. Okay. Now, first, median, mean, and mode, they are very simple. Okay. So I'm not going to go into big detail. Instead, I'll tell you what are the implications of those and what are the caveat of using those. Okay. So just before we start, we have some notation. We have standard notation. Number of observation is small letter n. Okay. And each observation will be x1, x2 up to xn. X1 is the first observation up to xn. Okay. And then we'll use what we call summation notation. Okay. This is called sigma or sum of from 1 up to n, xi is adding up. Okay. So this is the standard notation we're using, and it's also used in all the textbook. Okay. So it's not something I invented, but just everyone knows it. In case you don't know, it's there. And there also standard notation we use here. It's called the floor or round down round function. Okay. For floor function means we just only take the integral part, just the integer. Okay. That's basically just the smallest, the biggest number smaller than is. Okay. The biggest integer that's smaller than this one. And ceiling is just round up, just whatever your decimal go up. Okay. 3.0 is also 3, but 3.01 is 4. Okay. So basically, if you have anything non-zero here, it's just add the integer by 1. Okay. So round down will be very useful function we use. And you may ask why we all do care about this, because you see this function appear in the Excel easily, and you'll be using some of time when you do Excel function, and useful for your automation. I mean, if you learn computer science and you learn C or other software, this is often appear, right? And the summation notation you learn for computer science is just like for loop, right? Or while loop, whatever loop you like. But this is something not complicated. Okay. And here we have two more notation here. Sorted data is in our purpose, we just sort from the smallest to the largest. Okay. If data, whatever collected, we just sort it from smallest to largest. Okay. In our example, I think I always put it from the small to largest, always sorted already to make it easier. But in modern Excel or modern software, you can easily sort the data. Just one click. Okay. And frequency, I think we know it. It's just like suppose the data we have the multiple observation have the same value, and how many of those is the frequency. So I hope this is something you have already learned in your high school. I don't want to go over them again, but in case. Okay. And this is something also you learn from your high school. It's called the frequency table or the condensation table. Okay. So frequency table is just, as I said, just counting and telling, just counting how many number of them, right? Say how many people, say suppose I count in this room, how many there male and female, and I count how many male, how many female, right? The frequency of male, frequency of female, right? And the next one is probably the last table is what we call the condensation table. This is a very useful one. And we use it over another purpose. Okay. Is you have every observation in this diagram has two kind of grouping. Either you're male or female, okay, in this study, or you're pass or fail, right? So here is so there are 15 male that pass, okay, 20 male that pass, and so on and so forth, okay. And this table will be very useful, okay, when we do over and things. But mainly, as I said, this is only useful for categorical variable, right? Because you have continuous category, then you cannot really draw it. You're going to write it down a table. Now, I hope every preparation up until now has been done in your high school. So we start real thing here. So we start the definition of mean. Okay, mean is nothing, but everyone know it is called arithmetic average, a technical term. It means that the add up every single observation, right? It's a fraction, right? The numerator is adding up all the numbers you have divided by how many of them n. Okay, Everybody knows it. I'm not going to go to detail, but you may ask, what actually does it mean? Okay, why adding up everything divided by n is actually a measure of middle, right? Because sometimes it's middle. Okay, the idea is very simple. The idea is saying that if you rewrite this equation, I'm not going to do the math, saying that if you take every single observation minus the mean, okay, add that up with 0. Okay, to put it in perspective, let me draw one. Let me draw something. Okay. Now suppose the data is like this. You've drawn the number line. Okay, x is here, right? We have x1 here, x2 here, say x3 here, x4 here. Okay, suppose the data is like this. Can you see it from the top? Okay, so that there's a data here, x1, x2, x3, x4. Okay, so what should be the mean? Okay, the mean here just means the following. The mean is exact location here. The location such that the distance left. Okay, maybe I do it in this way. Suppose this means here, okay, and this distance is called x1 minus x bar, okay, or x bar minus x1, the absolute value, right? So distance from this, and this from this, and distance from the left, and you can do the same for the right, for the mean. It means why is the middle is exactly the total distance from the left, same as from the right, okay? Because that means that this is negative and this is positive. So that's why add up is 0. So let me repeat the statement. Why x bar is the middle of data is exactly the center of data such that the distance from the left, sum of them, is equal to the right, sum of the right. Okay, so basically just like x1 minus x bar plus x2 minus x bar, these are negative. x3 minus x bar, positive. x4 minus x bar, positive. Add them up is 0. Okay, so adding them is 0. So exactly what I mean by here. So this meaning, okay. So that is mean by center. So here you can easily see from this idea. Why I talk about this is the idea is distance matter. Okay, so that's why only the numerical variable would make the mean would be most sensible. When we have a nominal categorical variable like likelihood scale ordinal data, the mean is not that meaningful. Okay, of course, if many observations and things are such and that, then some condition, then still would be some meaningful sense. But it will be most meaningful when I talk about mean, when talk about it's a numerical variable. Okay, as you can see also, and the second thing is equating the distance from the left and the right, right? That means that if I have one single data that is super big, okay, maybe somewhere here, okay, then the mean will be maybe far off here, okay? So if you take out this thing, the mean is far off from this stuff, right? So that's why mean is not when the data is skewed or have a lot of outliers, right? Is that clear why mean is good and bad and why use it and what's the interpretation? Okay, of course, I think you learned it in your high school, but I just want to emphasize the meaning of this and why we have to use it and when not to use it. Okay, and the second thing is if you place the observation value by the mean, everything the same. So basically, if you replace every value by the mean, okay, it's just the mean, right? So it's just nothing but technical. For those of you look at the notes and you can see there's a gray area thing, okay? It's something that we are not going to test it, but I hope you learn it for technical reason you learn it, okay? So the main thing I already highlighted in blue. So you should able to understand those. Of course, you don't have to memorize because it's open book exam. And for the green one example, I hope you understand what's going on in the green example. That's actually we see in the next slide. But before we go ahead, any question? Any question about the interpretation mean when to use it, how to use it, and why. Okay, I hope this is something already you learn. Okay. So the example is green color, and I expect you to able to reproduce those. Example, calculate by yourself. Of course, they are in the green color. You, as you expect, I asked them in your assignment. Okay, you should able, if you stuck in your assignment, then you should look at the example I discussed in the class, and then you should able to do it. Okay. So in this example, I have two data sets. Okay, one is 1, 2, 3, 5. The other one is 1, 2, 3, 4, 50. And I can use this calculate using a calculator, right? Adding up divided by number of them. You can easily see the below one is much higher than the first one, right? And as I said, if you're something very big, 12 is not very representative because 12 is way bigger than 1, 2, 3, 4, right? Bigger than majority data. Basically mean random, mean useless. Okay, so that's why we take this look at like the income data, right? So we have ordinary people 1, 2, 3, 4, and the Bill Gates, Elon Musk at the end, right? So the meaning of average is not meaningful, right? So that's why I look at the GDP per capita is not a very meaningful thing, right? Look at the average income would be more meaningful, right? We look at data, right? Or don't look at the income, or look at the data. Suppose you are the business, look at the average spending of the customer is not very meaningful, right? Because maybe there are several customers basically spend a lot of money and most of them are not, right? Then you should focus on the guy who is spending $50, right? You may forget about 1, 2, 3, 4, right? That's what we call in economics, we call some niche market or price focusing or price discrimination, right? So focus on a particular group of people, right? That's the idea there. Okay, so that is application. We look at the mean. Okay. Now, the next two, as I said, technical is very practical. Is in the real world is suppose of data 1, 2, 3, 4, 5, 50. Okay, how do we handle it? Because that happened, right? Okay, and how to do it is there are two ways in general. One is called trimming. Okay, so we have Elon Musk, so get him out of our data. That's it. That's called trimming. Say bye-bye, and then that's done, right? And the mean is 2.5, so it's good. Okay, and the question is probably you say how to define trimming. The standard way is you take away top 5% and bottom 5%. 5% trimming, or 2.5 or 1% depends on your data size. So just like the top 1%, bottom 1%, you take away, then you'll be done. Okay, and the other is called winsorizing. Okay, instead of say Elon Musk, you're out, you make Elon Musk making $4 as well. Okay, instead of 1, 2, 3, 4, 5, 50, you make 1, 2, 3, 4, 4. Okay, that is not uncommon when you look at data from say in a reference department. Okay, the income is trimmed at the top. The data you have already is trimmed already. Actually, a lot of data actually you have it's winsorized already. Okay, and actually a lot of data indeed if a trim is a winsorized data. For example, look at life table, because I'm actuarial science, right? Look at the data, study a guy, and you want to see a treatment, whether say cancer treatment, where the guy would die in 5 years, right? And maybe a lot of subject doesn't die within 5 years, right? So then you just say they live for 5 or more, right? Already censoring is something naturally happen in our world, okay? So, but if you have outlier, you can also do censoring by yourself, okay? Or, as I said, you would want to do it if your data is where we have a lot of outliers, okay? You should apply, so your data, okay, collected usually is not ideal, it's an outlier, okay? You need to massage the data in somehow, okay? But you shouldn't do massaging in arbitrary, okay? There are certain method procedure to follow. As I said, you either take out 1%, 5%, 10%. That's how you massage the data. You're not free to massage. There's standard procedure to massage the data, which is acceptable in general. Okay? You can say, okay, this outlier, I take it out. Okay, the outlier, I take it out. and then you do whatever you like. No, there's standard procedure like this to make sure that you clean your data in a way that is acceptable. Okay, so this is the thing, but of course it's a technical advanced thing, but just put it there in case you're interested. And the next one, also you learn in high school as well, also commonly use it, is called weighted average. Okay, and average is something add up everything divided by number of them, but that means that you add every observation have the same weighting, right? And that means not very appropriate, right? The most often you see is called GPA. Okay, everybody cares, right? And I would say you want to pay a lot more attention to my class, the other class. The reason why is because our class is for credit, right? Other class with free credit. Okay, you get an A in our class better than get A in other class. Okay, so because weighting, right? Because you multiply by different weight. Okay, the calculation is very simple, right? Just like the standard normal, the standard average is every weight is 1, right? So if everyone, this become n, right? But now you multiply each observation by its weight and add together. Okay, this is how you do the GPA, and I know I hope everyone know how to calculate. So this formula should be familiar. Okay, I'm not going to explain in detail what's going on, and the interpretation will be the same. Okay, will be the weighted distance. Okay, just the center of the weighted distance. Okay, and now this is very often used, right? Say in the stock market, the way often we call moving average price, right, is looking at not just simple average of previous prices, right? Look at the weighted average where the recent prices carry more weight, right? And portfolio return is not simply average return of each investment, is the more you invest, more return, right? It's weighted by your weighting portfolio. And often in Hong Kong, everybody knows Hang Seng Index, right? XSI. XSI is a weighted average of the stock movement weighted by the capitalization, right? The larger the stock, the more the movement will be much more reflected in the index, right? When you have Hong Kong and HSBC move, right? The market move, right? Or China Mobile move. China Mobile, I don't know. I haven't looked at the stock market for a long time, but if those big stock move, then this thing will move. I think now is Alibaba move and things move. So that is the idea. Okay. So the data, just telling you how to calculate this is very simple, right? We have 5 data point, 1, 2, 3, 4, 5, and each data have different weights, right? Surprisingly, we put a lot of weights on the first observation for some reason. And you will see if you just simple average adding up divided by number of them is 3, but weighted it will be very different. It's 2.5. The reason is you have more weight on the bottom one, so the number is lower. Okay, so that is nothing new here, but just to illustrate how to calculate it. Okay, I hope you learn it, and I think in this is also in the junior school curriculum in Hong Kong, so everyone should know it. So the other 2 average, I'm not going to go into detail, but also have some business application, is called geometric mean and harmonic mean. Okay, geometric mean has a lot of usefulness when you talk about finance, right? When you talk about compound interest, when you talk about return with compound interest, you talk about investment over 2 years or multiple years. What's the average return? When you have compound interest, you shouldn't use the simple average we have done. You should use geometric average. Okay, and the harmonic mean is somewhat not very simple to see the notation. Not going into detail, but when you use it and you look at the average PE ratio of your portfolio, that would be your average. Okay, if you're weighted, then just add weighted. But not going into detail because I just put it there in case there's some more average you want to use. But the geometric one is very often used when you talk about in your finance data. Okay, but I'm not going to go to detail because it's not our interest. When you go to later talk about finance or investment, you will use these two more often. So just to give some idea about the geometric, because I think geometric is a lot of use in finance. So suppose you have the two investment choice, option 1, option 2, option 1 10% for year 1, 90% for year 2, okay? And option 2 is 50 for 2 years, okay? Look at simple average. You would think the two are the same, right? Because option 1 is 10% plus 90% divided by 2 is 50%, okay? Over 2 years of average 50%, okay? So you would say if there's no reinvestment, the two options are the same to you, okay? But suppose you have reinvesting opportunity, you reinvest more. Then using compound return, which is saying that you multiply them and then take a square root, okay? In that case, the second is better than the first because the first one grow better, right? The first time you go 50% and go for the 50%. So the first, there's a more time for it to grow again, okay? Although the first one grow a little bit and go a lot, but it is better for 50% per year, okay? So as we are not finance class, so just left you to say average of many type. You have to pick appropriate one, okay? If there's no reinvestment, then simple average will be fine, okay? Otherwise, it would be okay. Okay, and I think I'll end with this slide because I only have 3 minutes. So let me finish this data definition of a median, okay? The median, probably you learn, is exactly the middle of the data, okay? If you have odd number observation, the median will be very simple, okay? The reason is if you have 3 data points, odd number of them, there's exactly middle one. The second guy is the middle, right? If you have 5 data points, the number 3 guy will be the middle, okay? And the question is that if there's even number of data, say the 4 observation, what's the middle, okay? The middle will be, say, 4 observation with the average of the second and the third one. We take a simple average of the second and the third one, okay? And in terms of, so we generalize it when you have n data. When you have odd data, n plus 1 over 2 is a well-defined number. If 3 plus 1 is 4, 4 divided by 2 is 2, second one. If a 5, 5 plus 1, 6, 6 divided by 2 is 3. So this is exactly what we want, okay? And if an even number of data, then will be, say, 4, right? Middle means the second and the third, right? 4 divided by 2 is 2. 4 divided by 2 is 2 plus 1, 3. So 2 and 3. So it's the average of the middle guy. Okay? So the formally, okay, why you want to, you can easily see that this is exactly this guy. Why? Because n plus 1 over 2, if it's integer, you run up and run down the same thing. Okay? Then exactly what you get. Right? The same thing. Half of the same thing plus half of the same thing. If this is not an integer, you run down, it's just this guy. You run up, just this guy. Okay? And you may ask why I care about this. Because I put this because if you write a formula from scratch using programming, you need to do this. You have the Excel, you can run up and run down and calculate that. Okay? That's why I put it in this way. Not because I just make it more complicated. It's because if you ever to write Python or Excel, you need to do that. Okay? We'll continue to talk about this, but just one minor, very final thing is this is exactly the middle of data. We don't care about how big the biggest one, how small a smaller one, exactly center data. Okay? It doesn't affect anything. Okay? Now, time ups. Okay? See you on Thursday. I will stay around to answer any question you might have. For those in Zoom, bye-bye.